In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and
All right, everyone. Hello and welcome to Aether Cosmology Roundtable number 83. Tonight, Shane's going to be doing a presentation on what are meteors. This is going to be a follow-up to his previous presentation on meteors. And if you haven't seen that, go to my channel or Shane's channel and search meteors. And you can watch his previous prezi on that. So, Shane, whenever you are ready, sir, take it away.
Cool. Yeah, great. So we're going to speculate on what are those lights in the sky that everyone sees and that they build sort of mythologies based on. Also, it's going to be sort of an open roundtable, so if anyone wants to participate or shout it out or chime in, that's cool too, with our normal presentation. So, I guess first we should define some of the terms, and it already gets a little bit confusing what we're going to be talking about. So, meteors, right? Typically, they're streaks of light in the sky, also known as shooting stars, and they claim to be small particles or fragments from other comets or asteroids, and these are other named terms down here. Within there you have meteorites, which are meteoroids. Well, what's a meteoroid? A meteoroid is any small or like rocky or metallic thing that they say floats through space. But within that you have meteorites that supposedly survive their journey and land on the surface. Then comets are the giant icy things that have a observed periodicity out here from the outer regions of the quote solar system, right? And they supposedly trail dust and gas, and that's what makes this one. But they have observed periodicities that vary. And then you have the asteroids way out there at the edge of the solar system, supposedly floating around, rocketing about, and occasionally making their way inward towards the planets to kill dinosaurs and cause extinction events that no one can find. But typically we're gonna be dealing with these. Right, but the whole premise, the whole point that I'm putting forth here that I have before is that these are all lore and mythology built upon the only real observation that anyone ever makes is meteors, lights of streaks in the sky. And we're going to spend a little bit of time going over sporadic and radiant meteor impacts and where they occur and where we see them. And from this observed, very real phenomenon, they constructed the whole lore of, oh, well, then these must be these, which then do this, which then are out there, perpetually always getting ready to cause us danger. So to go through the sort of mainstream explanation again for what they are and how they are, you got to use cartoons as best described mainstream science. Oh, my mic was muted. As best described mainstream science, we're going to go through, the best way to describe it is with cartoons. So let's see here.
Hurtling towards Earth, a shooting star catches the attention of anyone looking up. But where does it come from? Out in the solar system, asteroids, comets and planetary fragments can move into Earth's orbital path, pulled in by gravity. As basketball-sized meteoroids approach Earth's mesosphere, frictional heating burns them up, producing the impressive light show of a meteor. These small meteoroids never make it to Earth's surface. Scale up to car-sized meteoroids, and these rocky bodies power through the atmosphere, burning but leaving enough behind to deposit a meteorite on Earth's surface. Yet to produce impact craters, meteoroids need to be much bigger. House-sized objects, expelled from the asteroid belt, will enter Earth's atmosphere with a literal bang. The sonic boom can be heard for miles before the meteoroid strikes the Earth, pressing the ground.
Magnetically forced jet or whatever.
Kinetic energy is transferred into shock waves so powerful that the projectile and ground beneath can vaporize and melt. A
Imagine that.
crater is excavated by complex interactions between tension release and shock waves, whilst impact ejecta can be expelled past the crater rim. Other material remains in the transient crater to later become crater fill impactites. Modification following large impacts sees central uplift of the crater floor and collapse of the unstable crater walls. Faulting continues far into the future, alongside hydrothermal activity, which changes the mineralogy of impact site. Earth has 200 known impact craters, a fraction of the 30,000
Interesting layout.
surface visible from your backyard. Volcanism, erosion, and the atmosphere all help to disguise Earth's past meteorite impacts.
Oh, they're hidden.
Yet the Chicxulub crater is a scar from an impact 66 million years ago, an event so devastating that it wiped out over 60% of life on the planet. Tsunamis, earthquakes, and forest fires followed, which inhibited plant photosynthesis. Atmospheric dust and temporary global cooling occurred due to nitrous oxide released from pulverized rocks.
Gotta love one myth wiping out another one, right?
Devastation.
Yeah, look at that tsunami wiping out that dinosaur's house,
Shocked
man.
rocks have increased porosity, helping microbes to colonize this biological niche. Crater lakes and hydrothermal springs provide unique, protected hotspots of evolution. And meteorites themselves bring carbon to Earth, an essential building block for life. There are economic benefits too. Canada's Sudbury crater houses some of the world's largest copper and nickel deposits. Hydrothermal fluids have taken advantage of pathways
money
created
falls from
by
the
faulting
sky.
and fracturing of the impact crater to concentrate valuable
Only the heaviest
resources
metals, apparently.
into metalliferous ores. Similarly, oil and gas can migrate along these pathways, creating important hydrocarbon reservoirs. Studying impact craters is essential to understanding the frequency, consequences, and value of meteorite impacts to better
Right. So the frequency, right? So the last thing was it occurs like once every, 600,000 years when no one can observe it. So they've taken the only thing that is observed, get flashes in the sky, you get observed periodicity, you get meteors, right? You get meteor showers, you get flashes of light. And from that, they've contrived a whole story of rocketing space rocks that are just orbiting the galaxy, the planets, that are just shooting around at all times. They cause death and wide destruction, and they claim that our Earth is riddled with the marks of these interceptions, right? So each one of these they claim is a giant space rock that has intersected Earth and left this giant crater. In the science cartoon that we just watched, they explained how this would have compression lines and how it would recede out, and how none of these look like that. None of these. Also, there's no debris around any of these, but they said actually don't worry about that because the debris will definitely all vaporize at an intersection of 90 degrees. The cartoon literally claimed that it would just vaporize.
Water and atmosphere will just take care of the rest. It'll change the mineralogical composition of the entire crater and stuff. So like it wipes out the fact that it was any kind of non-Terran substance anywhere near it.
Yeah, they say that it fills with water as a natural consequence of what? Because the alternative explanation, it very much is water. So if water happens to fill these, or has been, or if the damage looks like something that might have come from water, they're trying to cover that up too by saying, well, actually, after an asteroid hits at 90 degrees and implodes itself, water naturally comes. That's their argument.
And oil. Don't forget oil.
When the asteroid wipes out a dinosaur population, those dinosaurs bleed brown blood into the earth, and that becomes oil, and there's only a little bit left of it. Man, anyway.
Brought to you by the Rockefellers.
They also claim that the moon itself was evidence of these same, what do they call them? Craters. That this is definitely all space rocks that hit the moon. If you look now, you'll find videos of people claiming to record asteroids hitting the moon. But, I mean, I haven't seen any that look credible, and there's never been a new crater registered. These are all named by Jesuit priests. So if there's a new naming for we'd have to know a new Jesuit priest, or so to speak. So I don't think that's happened. But if you look real closely at the moon, these don't look like craters. Again, the same problem is they're all the same 90-degree sort of impact crater, and these have been known to sort of change and mutate. So they're more like plasma bubbles that sort of you can see sort of erupting or whatever. But
Yeah, they're all the same depth too.
yeah, there's not the shadows are supposed to be the super deep ones, right? But you don't really see that. They're all super shallow. They're all definitely at the same depth. So that's not good evidence for what we're seeing on Earth either. This looks a little bit different. But don't forget that NASA, of course, has their eyes on all these asteroids. Not only are they real, but because of satellites and non-isotropic speed of light range measurement equations, we can find exactly where they are at any given point out in the solar system, out on the outer rim, right? So not only are they real and they exist, but we named them. So you look as
now are they canonized by their relationship to a Jesuit priest as well, or no?
Depending on them, some of them are named after sun gods and ancient Egyptian things, right? So they're keeping the convention consistent, but these particular ones, I think, are more Roman god situated. And then you got Lucy, Bennu, let's see, Vita, Apophis, Tempest. I mean, they're kind of all over the place. Ooh, Polymele, Ubiquities, Vesta, Apophis.
Donald Johansson.
Yeah. So not only are they definitely real, but we know exactly where they are at all times. You know, the three-body problem be damned. We can predict these trajectories, right? We can use the mass of this asteroid, as NASA is claiming, and they can predict the orbit around which it's going to circulate, and we can use... This is actually what they have out there. So the three-body problem doesn't exist. We can actually... All these interacting gravitational fields, no problem. No problem. Can't do it in coding, but for this model, for you guys, for the general public, NASA can do it. NASA can do it, no problem, no questions asked. So again, these are all the bodies that they say actually cause this. Right? This is, I think, one of the famous craters that exists. That there's actually a gift shop and a museum and a place to study it, right? And it's all around the rim. And around nowhere, anywhere near here, will you find any trace of the apparent rock that did this and then penetrated exactly this far into the Earth and then destroyed itself around the crater.
It vaporized.
Vaporize. Imagine, from 100 million light years away at screaming velocities faster than the speed of light, slamming into the planet, and it just goes boop. Like boop. And it gets cushioned, then it just kind of sits, and then like what? Anyway, moving along, you got this guy, right? So the general explanation.
Feet deep. For the longest time, it was assumed to be a volcanic crater. It wasn't until the 1960s that it was confirmed to have a more celestial, yet just as explosive origin. 50,000 years ago, as woolly mammoths and giant ground sloths wandered these lands,
Gotta slide in the other ones.
this asteroid collided here. The impact energy was about 10 megatons, equivalent to more than 20 million tons of TNT. Named simply Meteor Crater, it's the first geologic scar ever confirmed to have been created by a collision from outer space. Hundreds of other craters have been identified since, but Arizona's remains one of the most spectacular.
Hey, Shane, maybe you could run that back. I didn't quite catch their mathematical wizardry there. The guy mentioned 10 megatons and turned that in the same breath into 20 million tons.
Is that what he
10
thinks a
mega,
megaton
20
is?
million? Yeah,
Nearly
yeah,
a
please.
mile
That,
across and over
unbelievable.
500 feet deep. For the longest time, it was assumed to be a volcanic crater. It wasn't until the 1960s that it was confirmed.
Man, if I don't make it less than full screen, I can't control it.
oh, wow.
50,000 years ago,
Took note of all the other ones.
mammoths and giant ground sloths wandered
it
these
comes.
lands. A massive asteroid collided here. The impact energy was about 10 megatons, equivalent to more than 20 million tons of TNT.
See what I mean?
Named simply
20 million?
Meteor Crater. It's the first geologic
That's
scar
double.
ever
How did that
confirmed to have
work?
been created by a collision
Well,
from
I
outer
guess what he's
space.
trying to say is it's a real super duper lot, and that you should be impressed and scared.
Like that is the unit of measurement when they say 10 megatons, like a nuclear blast, or
Right.
the warhead has an energy release of 10 megatons. They're talking about tons of TNT. So how did it turn into 20? Wow. Normies really got to be asleep to eat this shit.
So it's so forceful that it only created this shallow crater, though. That's the other part. I mean, so once you see this part, though, right? Like, shouldn't any of them look like this? Shouldn't all of them look like this? Shouldn't some of them at some point have glanced off the Earth's surface at an angle and not been a direct hit and just look something like this? Like it should, yeah, like this meme, right? Like they all look like this, but none of them look like this, and that's a very weird distinction. I think. I think so. If the normies were to speculate about it, I think I had one about a guy in a helicopter explaining it. Let me see. Yeah.
That
It's too bad that meme has 3 shots of the same crater.
Back in the early part of last century, Daniel Barringer, he thought that there was actually a full chunk of iron buried underneath that. So he bought the mining rights to this crater. He thought he was going to go down and find $1 billion worth of iron in it, and that's why there is a mining setup right in the middle of the crater. So hopefully we'll get to see that tomorrow. As it turned out, they didn't quite understand the impact physics, and the asteroid essentially obliterated and is
I love that part.
pieces all over the area.
Oopsie.
Some of the larger pieces are actually in the visitor center.
Well, then they're not very large, are they?
Maybe there was a robot that shot it.
Yeah, I love his wife's coming in with the comments like, well, I don't know, guys, maybe there was a robot that just
shot it
and
what?
it vaporized it.
What?
Well, when the normies are speculating, man, robots and AI and aliens are like number 2 and 3 on all explanations. So it's like
Was
I
a
guess
time
those are the
traveling
kind of
AI
people-
robot.
like they don't know any better, right? So
Those
they
are the
think all
kind
that's
of
likely.
people. Yeah, those are the kind of people that would take a helicopter ride to see that, though. So there you go.
That guy was packing one hell of a pea shooter if that's the impact crater from a projectile. Holy crap.
And again, no one has ever seen any of these form in nature. No scientist has observed it. It's never been seen, but everybody knows that if you ask the guy in the street what happened here, he'd be like, oh, well, you see what happened was a giant space rock impacted at a perfect 90-degree angle and then imploded itself to destruct all evidence and then left this shallow crater in its wake. Like, what?
Oh, and then sometimes it fills with water. Yeah.
And then it will fill with water, yeah. So no one's ever seen it, according to all the science, right? So they'll tell you all about it, where they are, what happened. No one's ever seen it. They have, however, figured out exactly how and when and where it happens and what velocity and speed is required. It's amazing science, right? And again, remember, NASA's tracking all these at all times. These are all orbiting and all their predictive paths based on the supplied solution to the 3-body problem that apparently that public-facing simulation had that NASA can't figure out for when it comes to realsies.
Yeah, they're also tracking all of the trash in LEO that we never see in any of their video footage from the ISS, right?
And every satellite, GPS, and Starlink that's ever been launched, that's always in a web around the all that's also being tracked.
We're also tracking a Tesla as it orbits Mars.
Definitely tracking the Tesla. Yeah. Yep. The funny thing, though,
you haven't been to
all that
TeslaTracker.org, bro?
with all that happening, though, right? With all this happening, we only see meteors. We only see meteors go one way. We never see them come up, right? If we're a spinning space ball, they should be omnidirectional, no questions asked, no exception. They should be coming from every which direction. On flat Earth, they come from the sky. They never come from the ground, right?
Is that a preferred direction for meteors, you're saying?
There's a preferred direction for meteors. There shouldn't be, right? It should be in every direction, radiantly, omnidirectional, no matter where you are on a spinning space ball. But we don't see that. We see them going this way, this way, this way, never up. We always want to see up, never up. Anyway, back to different craters. So let's look at a different one, actually, since I showed the same crater 4 times, Stone found me out. It is the most famous one. So this is, I think, Crater Lake or whatever. No, this is Crater Lake. One of them is Crater Lake. But what happens a lot of the times is it fills with water, right? Now, if it was a geyser or if it was an eruption point that literally, or a sinkhole even, then water would be filling in would be a natural consequence of it. And that's what we see in most of these, right? Even this one.
So
Not so much in here.
Quick recap. In most of these, we see water and no giant meteor fragments or dinosaur bones or like anything like that.
Excellent observation in comparison. Yes, much more frequently you'll find water and you'll never find dinosaur bones, and you'll very infrequently find little bits of the so-called meteor that almost always, after intersecting with the Earth at a direct angle, will implode in a way that it disintegrates all of itself to a high 99 to 100 percentile of disintegration of all evidence. It's crazy.
Well, dude, the
Shane,
fact
can I
that
ask you something?
Yeah.
How come the meteors behave uniformly in their orbit and they impact uniformly at a 90-degree angle if this is supposedly, from a random event from like billions of years ago?
Well, maybe there's a robot, right, that orchestrates all of the meteorite's impact, and it has a personal vendetta for Earth, and it tries to impact with the most velocity, and it makes them all 90 degrees. That's my theory.
yeah, see,
They're both uniform.
yeah, the fact that they're all 90 degrees, boys, we're being sniped.
But yeah, if, they're so good at directing these space rocks to come hit us that they never miss, and they always hit exactly like direct on. And insofar as they don't drill down, they don't go all the way in, they hit, and they just bounce, poof, make a little shallow crater like this, respective to the size of itself, and off it goes.
Center mass, dude.
Now, they have other evidence for things in the sky, right, that we inexplicable, like this one right here.
We saw in Russia a few years back and Arizona a few weeks ago. What are these?
Well, we've got shooting stars.
down.
Like I said, stars aren't actual terra firma. So when you see a light shoot from somewhere to somewhere else, it's simply that. It's simply a light shooting. It's not a rock in outer space coming somewhere.
No, but the ones in Russia that actually broke school windows and it almost felt like an explosion.
Right. And then you've got these ones where you can see mostly from Russia, it seems like, from dashboard cams, you'll see these burning balls of something coming. And yeah, they've even crashed windows and something. These, I think, are some sort of military thing that they're shooting to make us believe that meteorites exist, because they're always coming down at an angle like they've been shot from a plane. If meteorites existed and we were on a spinning ball Earth, then meteors should be shooting in every single direction.
But also all coming down at the angle that no one has ever intersected the Earth at.
Yeah, I was about to say, none of these are 90 degrees, dude.
And when it goes diagonally,
this is a fake meteor shooter.
Horizontal and every other
copycat
way, but we don't see that. So I'm quite skeptical of meteorites or asteroids or any sort of thing that they claim is up there floating around and comes down here and destroys dinosaurs, their other myth. They like to use their myths in conjunction like that.
Two more questions. No, I'm sorry, finish your statement.
So as far as the Russian ones, I would tend to think those are some sort of military experiment. Some sort of thing that they drop. Something like this. Because you don't see them all over the world, you just see them there. It seems like it might be something they're working on.
They are loud, though, and crazy, right? Like, we heard one. They have these, right? You gotta know if that's supposed to be a meteor, but it's not, right? Like, I don't know if anyone's ever heard one of these. They do claim to cause damage, right? Have sound waves, break glass, etc. It makes you kind of think of that Truman Show episode or that part, right? When he's walking to his car, and then this happens, right? And he goes and investigates, picks it up, notices it, doesn't notice anything's happening. It's kind of weird because we kind of have the same thing happening to us. So whether these are the things that are making noises, but why this same shaped sort of circular firework looking thing with a tube and a fuse gets seen all over the world and all the different cultures by all these different people, and they all call them different things. Like this country's space program claimed it as a fuel tank. This one's actually a hydrogen dispenser. This one's space junk, right? They're all the same thing, obviously. And all the different countries have claimed them to be different things. Like you'll see, like, I don't know how to pronounce this country, but in Garat, giant balls of metal that are spotted falling left people baffled until it's okay. We believe they're fragments of a satellite. Oh, okay. So in this country, they're fragments of a satellite, and that's totally safe. And over here, then the Russians and Peruvians, they said the fireballs are plummeting. But they actually, when they looked at the huge rocks, they were like, actually, we don't know what it is. So undecided over here, but it's the same thing as before, same thing as these, same thing as this.
To me, those just look like the ones that were unsuccessfully ignited. And I think the natives should have the presence of mind now to whip out the flamethrower or the incendiary ammo.
Gotta let it on
get
fire.
50 feet away from these things and just open fire on it until it goes off. And then you get to see the whole thing vaporize on the spot, and you can record the sound, etc., and match it across what went off in the sky, the ones that did ignite. You know what I mean? Simple plan.
I think they look like fireworks, and they look like spent capsules or something, like something that made a large streak in sound.
Then it would be really hot when it hit the ground if it actually did go off, if this is what's left of one that went off. Because that guy right there, he's, there's no scorching on the earth there of the vegetation or anything around it. It landed cold.
They dig them up or whatever. Yeah.
Oh, interesting. I didn't think of that. Yeah.
That is
So
weird.
there's another aspect in regards to this. More information. Last time I looked into the meteors and impact craters and things like that, they say there's like 6 major ones that happened, which caused extinction type events. And they say the one that wiped out the dinosaurs, they think, is the one that hit down right off the coast of Mexico and California. And now the rim of that is now able to be diving into for like these underwater caves. I'm not sure if you guys have ever heard about that, but those are
cool.
in. Yeah,
Those
it
on the
sounds
West Coast?
cool. Yeah.
Neat. I'll have to get my brother to look that up, see if he can go.
Yeah, it's in Mexico somewhere. That's all I have. I gotta look back to work.
Crazy. If you look up balls from space or space balls on Google, you'll find your own pictures of these, and you can easily find your own incidents, and they're all over the world. And you can put your own collage together of your explanations of whatever you think, because everyone gets to make up their own. Now, again, this is all in an effort to explain these things, right? Because we started with these are real. We've observed meteor streaks of light in the sky, and we're going to go into what these actually are in just a second. But we've looked into these to say that they claim these to look into the explanation of these. So these are all clearly related and built upon the presupposition that these are real and are actually the tiny, small version of rocks rocketing through the solar system that they light up when they hit the atmosphere, burn up, cause mass extinction, but always extinguish themselves. That's what all of this mythology is built on. So what are these really? What are the shooting stars, these bright flashes of light? Well, like we said before, they are studied. They're studied by radio survey. Right, this is a Harvard survey we're going to look at, and there's a whole bunch of other papers. And they study the impact region and amount of the meteors and predictable meteor showers throughout the season of where they hit the Earth. So this is an ecliptic coordinate system, which just means that it's based off the sun's path. So instead of aligning with the equator and being symmetrical, it's using a tilt based on the sun's ecliptic as its main equator, and then from there it's using these sort of symmetrical displays. And then what it's doing is displaying sporadic meteor, radiant sporadic meteors, which is what's over here. And then here you have the much talked about and frequently misunderstood ecliptic coordinate system of the most impacted sporadic meteor sites. So where do they all hit? In the North Toroidal, and then the North Apex, and then also the Hellion and Anti-Hellion. So this is where the sun is. And when you're talking about meteors, if it's the sun's over here, obviously it's bright. You're not going to see a whole bunch of meteor impacts. These aren't good for visibility. No one sees these. Anti-Hellion is where the sun is not. Obviously, it's pitch black. This is where you want to see all the radiant distribution of meteors. This is what this means. There's also a southern apex, which is supposed to be this around the south celestial pole, which we'll talk about in a second. So here's what they're looking at.
Can we go back to that for a sec?
How about this one? Does this one help? Is this one you want to
Yeah,
look
the
at?
antihelion, exactly.
Yep.
So by definition, really, we're looking at the antihelion is your zenith, essentially, at midnight.
Yeah. Yep.
Right on.
Yep. And then let's see. So yeah, so this picture taken out of context gets masqueraded on the internet as different things. People seem to misinterpret this as evidence for all sorts of things. Concave Earth think this is the dodecahedron in the sky, something about their interpretation of the celestial sphere in a projection of some sort. It's not that. It doesn't even look like this in observed reality, right? This is actually a combination of alt-as observations, which means they took regular observations, right? So they went into their observatories, they looked in the regular world, they took an elevation angle off a horizon, they took an azimuth from true north. That's the regular alt-as, observer coordinate system. And then they loaded their data into their system and they represented it in this ecliptic coordinate system. So this end result, it doesn't look like that. That's not what it looks like in reality. It means nothing. If you're going to assign a second meaning to that, you should understand where it's coming from, right? So this is an ecliptic coordinate system representing a collection of alt-as observations of sporadic meteor impacts. So we know about coordinate systems and coordinate system transformations, and we know that the ecliptic is a version of the latitude and longitude. They have their own ecliptic latitude, and again, based off the sun. In our version, it's just the same sort of right attention declination, but with a different offset. So instead of the celestial equator, it uses the ecliptic. And the conversion between them will just switch back and forth between these two. You translate it around there. So here's what the data actually looks like, right? So we're going to represent it like this. This is, I think, the same data as over here. And again, you have the north toroidal apex and sun and antihelion over here. And again, ecliptic longitude around the side. So when they study all this stuff, they're looking for many things. They're looking for symmetry and predictability and periodicity, right? So they have all these graphs about where it looks like in September relative to the sun. Of course, everything in the sky is relative to the periodicity of the sun. So wherever the sun is, whatever the sun is doing, it's causing and is around about all of the sporadic meteor impacts. All of the electromagnetic phenomenon that is occurring is directly traceable to the sun. So they said the maximum count rates are expected to occur in January and then in mid-December. And again, that's dependent on where the sun is, depending on where the observations are taking place. And this the sporadic radiant distribution of meteors in the atmosphere. And they say, in contrast, semi-annual variation observed using a similar radar near the equator, and that the count rate has maximum in the summer and winter and minimum in the spring and autumn. So literal season flexibility. So aligning with the seasons, you have meteor showers that, of course, when represented on the ecliptic, just sort of follow the sun around. So they have, sorry. So they have lots of studies about this specific phenomenon, and they have lots of data, and they all sort of agree with each other, except when they try to look for things like symmetry. And they say, hey, we have a north toroidal, we have a southern apex, we live on a ball, the north is like the south. Hey, shouldn't the south exhibit the same sporadic radiant meteor impacts as the north? And you'd think so, and absolutely not, right? So they would think that would be the case. They go ahead and measure it. It's completely not symmetrical. Go figure. And even in their scientific papers, like this one, at our buds at the Royal Astronomical Society say, hey, this is puzzling. The two sources are simply the same principle, and hence they should have the same strength. And, it should be the same. Should be. Not. Never is. Never is. It's all over the place. The South Toroidal source that actually exists, right? And according to them, they speculated in the 1960s, and then they observed it to be real. They found actual data in the Adelaide, whatever, in 1993. So that would be spread out around the outer rim for us, right? In the proper ecliptic transformation.
Adelaide is in Australia for those playing along.
Thank you, sir.
Yep. So again, in the seasonal variations, they're mostly monitoring the north toroidal source, which is the most studied, the most, what would you call it, the most data dense. So if we were to look at what would that look like over flat Earth in a conceptual model, into what I would definitely call more proof of concept than actual coordinate transformation. We'd have our a magnetic field and what we look at with our toroidal magnetic Earth, and this is where the meteor impacts would occur. As the sun circles around, they would occur here and here, and of course at the center spout and up here. This is where all the meteor impacts occur. There's also some around the outer edge, which we would have to translate, that exists down here, supposedly in the ecliptic coordinate that would be spread up around here. But if you envision the realm like this, then this makes a lot of sense. Start to see it sort of around and around, that the sun makes this path, and we have sort of poloidal currents going around this toroidal thing being created by the different dynamic forces of the sun and the moon. Then yeah, the position of the meteor impacts would make a lot of sense. If we look at this video here,
to further understand,
there we go. We're going to talk about magnetic ejection jets. So let's see. This is from Primer Fields, right? It's Michael LaPont, I think is his name. No, David DuPont. David LaPont. Man, I'm sorry. Everyone should go watch the Primer Fields at least. He's got like 10 videos explaining how electromagnetic fields and bulb magnets are really double electromagnetic fields, and what is in fact a toroid model explains all of what he understands to be particle physics, and he uses magnetic fields to explain gravity, and also it's a wonderful sciencey things that everyone should go look at and enjoy. But this one quick clip we're just going to look at, where he's explaining his double toroidal bulb magnet in a plasma field with a vacuum tube, and it's going to emulate what we think happens, on a macro scale across the realm. And what he's going to look at is something called ejection jets that are formed just by magnetism that exists in the polar center, and that's what he's going to be describing here.
To further understand these magnetic fields and validate this,
there we go,
chamber and the way in which they shape plasma.
This is what I think we live on, right? And then we live on the dielectric plane in the middle here, the plane of inertia over here.
In post-production, he should have been dropping his gamma and showing us exactly what's going on in there. Just like he's doing there, but on the fly. You know what I mean? Yeah.
Yeah. Yep.
Hyper-focused polarities.
Notice this plasma discharge happening around here too.
Magnetic fields.
Well, one is not causal of the other, though.
We have also witnessed
that the magnetic fields here are not the thing that is causing the plasma. He's already creating the plasma with a voltage offset and running it through the fields to show you the shape that it goes as he's producing it.
Yeah, he's definitely doing something a little different when he's inside his vacuum tube here.
Oh, he's having a party.
It is awesome, though. I like to watch it every time. It's mostly the shape and what he's showing with the magnetic fields and the interaction over here. And he's definitely juicing it up, and he's got all sorts of controls so he doesn't have to touch it.
We have seen how the shape of the reaction...
No, those are dual magnet pairs that'll anchor things to the outer cylinder.
I thought it was how he moved the inner apparatus. Yeah, so he's moving it around.
No, those are wires going to and from. You know what I mean? How he supports those. That's just magnet on each side of the glass holding a wire.
Then we have seen how a disk of plasma will form around the equator of the magnetic fields.
Right, so that's just the science explanation for what we're looking at here. So when we take this model here of this dual bulb magnetic field, this is what I'm looking at as a toroidal model, right? Because you have the top field and the bottom, and so you have charging and discharging, right? The two states, right? And he's explaining it as an atom, and he's got an interpretation of particle physics where instead of a probability cloud at the center of an atom, he's got actually an atom is these two fields, and these two fields interact together, and these fields themselves are the atom. And that's a probable much closer interpretation of the truth of particle physics that I've ever heard, right? And he has an interesting explanation for the double slit along that way of thinking. But carrying the model to how we're depicting the Earth to explain meteors, right? We have this magnetic field model. We have double bulb magnets, or we have, a north toroidal, if you will, and a south toroidal. We have these two fields that interact that we live in the middle of that create our, plane of inertia. To think about the right terms, right, on a sphere, these would be poloidal currents on the toroidal model, right? On this model with this toroid, we would have these poloidal currents going around, and that's the proper term, right? So we have a donut-shaped toroid with poloidal electric currents, flows sort of in the torus loops. And the same thing over here with the magnetic moment ring, which is, I think, toroidal movement, right? So we were going to represent it. We can see it something in a tokamak, something like this, right? With the central...
Yeah, go back one frame just for a sec. To clarify the relation between B and C, that C is actually the direction of core motion in terms of the circuit drawn by B. So put C inside B.
Right.
And that's
the other way
going on.
Yep. This definitely is going on inside this at the same rate, right? I had another one. Let's go to this one. So yeah, this would be a tokamak, right? An actual, what do you call this? A magnetic field power device. A tokamak, I guess they call it a nuclear fusion using plasma and magnetic fields. No. Yeah, is that what they call it?
That's one term they use, cyclotron. Yeah.
Nice. I've never heard that. That sounds awesome. So it's like a giant electromagnet, essentially, and it does electric current in the plasma, and they get energy from this. But they use toroidal fields, and they have poloidal fields, and it's sort of a giant working model of what we're looking at. So these toroidal fields right over here induce this poloidal current going around. Same thing as what we saw before. If we were to look at it, again, mathed out, we have the same sort of tokamak sort of explanation going around. Here's what it would look like. Not to go into the math, but just to explain the complicated way in which the electromagnetic field is working on our electromagnetic Earth, right? So again, if this is how we're representing it with our celestial bodies, and I think we mostly represent this, we would be able to represent the sporadic meteors at their normal intersection points. But if this is a double bull magnetic field and they're in the center, we would get a sort of ejection jet, as he was going over. When you put these two fields together like this, in the middle, there are powerful forces between both fields after this null point where matter or things are ejected. All right, he equates it to, in the stellar medium, if you're looking through a telescope and you see galaxies form, from NASA and the space art, within those fields you'll see the same interactions. So either they're the imitating nature in the magnetic field nature of the universe, or really up there the micro is the macro, and little tiny magnetic fields are having interactions and expulsion jets to create what physicists are calling quasars and all sorts of things today, right? So here he is again explaining that.
Alone cannot explain the formation we find in Hercules A. So let's take a look at how matter can be ejected by these bowl-shaped magnetic fields.
So now I'm going to show you magnetic ejection utilizing the CERN ball. So this one will shoot these magnets, ordinary magnets, about 25 to 30 feet across the room.
I like how his ammo cans are named dark energy, black holes, and dark matter.
So I'm just going to show you what I'll do. So pulls it down here, and I'll just put it in through the bottom, through the hole in the bottom. A little tricky. It doesn't really want to go in there. It's kind of against it. But then you get it to where it's a balance point, where it doesn't take any energy. But once you push it past that balance point,
Knowing that all matter has a magnetic component to it, you can now see how these incredibly strong bowl-shaped magnetic fields in space could accelerate matter to nearly the speed of light without requiring external electricity, black holes, dark matter, or even dark energy.
He's on the right track, right? Saying that electromagnetic forces can explain all the phenomenon they currently have allocated to outlandish things like dark matter, dark energy, inexplicable mathematical placeholders, etc. He's on the right track for sure. And he's using, the double bull magnetic fields to show ejection jets in matter. And up here, right, if you're looking at where the Harvard Radio Survey dictates all the sporadic meteor impacts occur, would be mostly where the sun is and isn't, and up this at the north toroidal and the apex. So right, the spots where they mark would be the center spout area, this upper toroidal vortex area would be very active, and then wherever the sun isn't. So if the sun and the moon are a dynamic cause of our sort of electromagnetic realm of all the forces that are intertwining to cause all the observed phenomenon that we see, all light is electromagnetic radiation, it's all sort of working together, then it would make sense that all of the meteors that we ever see in the world would impact in this general area where the sun and the moon is. So the thing counter to this is this little guy down here called the southern apex, and this would be the newly added southern observations of a southern celestial pole sporadic meteor impacts, which of course this isn't how this would look like. I just threw the ecliptic over this. It's not bad for where these three would look at, but of course the bottom doesn't exist on flat Earth. It's spread out all the way around here. So this would be really, this one is really supposed to be sporadic meteor impacts at intermittent spots all around the outer edge of flat Earth. That's what this is claiming to be. And I'm not sure on this one because I only found this one paper claiming to have seen it, and it doesn't have anywhere near the level of data as all of the other papers that I've collectively looked at that all agree on the other impact sites and area and density. But this one is it's from 1960, and it's the only one I know about that shows the southern celestial pole south apex toroidal impact meteor, and I can't even make heads or tails of this. This is nothing like any of the other surveys. They don't seem to have the same level of data. They're just saying it's definitely real and it's there. So we'll take them at their word for now. And we'll say that also there is the sporadic meteor impact way outside where the sun isn't for some inexplicable reason. It would make more sense if it was just in here, and then, this would be sort of intermittently out there. However, on the electromagnetic model of flat Earth, you do have northern lights and southern lights. So we have the green light, visible up here from the north toroidal, where you would see from the center spout, but we also have southern lights all around the outer edge, and they look different. You have a different aurora. I forget what it's called, but it's different than the north, and it looks different.
Australis.
That makes sense. Yeah. So aurora borealis and australis borealis, something like that.
The aurora australis. Yeah.
There we go. So from all the other sources, they have radiant density, radio survey, all this hard data that all agrees with each other, and it seems pretty consistent, and I would say is pretty real. But the other data from this one source disagrees with all of this and just says that it's known to exist. So I'm not sure what to make of that. We'll look into that, and we'll see what we can do with the southern apex, southern celestial pole meteor impact sites, and we can see what we can make of that. Of course, we know the south celestial pole is real. I'm just not sure about its sporadic meteor impact density integrity. So we'll look into that. And again, to remember, when we're looking at impact craters, none of them have ever been observed in nature, but they do know when and where every single one of them happened because, of course, we have data on sporadic meteor showers. Trying to connect the dots. Again, they know exactly where all of the meteors that impact the Earth, about 160 meteorite craters that cause impact craters and lakes. We know exactly where those are because we have radio surveys of this sporadic light show in the sky that comes and goes with the sun and is cyclical with the seasons. Are we following the logic? So again, we have sporadic meteor lights in the sky impact of light meteor showers that we can know, study, replicate. We can aggregate the data, and they always usually agree. And then we have these giant impact sites all across the Earth from varying sizes, from cars to the buildings of space rocks that all left identical craters that all look the exact same as geysers. So I'm going to play this other video, and this dude calls them geysers, and it's really annoying, and we're just going to have to deal with it, all right? So forewarning.
So this happened from asteroids, right? At least that's what we've been programmed to believe. But what if I told you that this was a phenomena that has happened from below and not something that fell from above? Isn't it interesting that what we have thought to be
I didn't consider the impact of playing 9 videos at once.
Geysers. Now let's compare both side by side.
Yeah, that's a lot of width.
Pretty similar, right?
They look identical to me. If you had to give me money to pick one or the other, I'm not sure I could do it. So the point of that is these are all geysers on this side, and then the craters impacting over here. So the argument then, of course, is all of these impact sites, are they really meteoroid impacts that struck us at exactly 90 degrees and then imploded themselves to leave no evidence, around which half of which now have water, or is it something else, right? So here's what the meteor impacts would look like. If you look at the various densities, I mean, we can make speculation and conjecture, but it seems to be they got a pretty good spread of where all the people are, right? Or if you look at the elevation map of the Earth and then try to figure out where that would be, right? The elevation map here is the outer ring is the highest. I don't know. It seems like if you were to flood the Earth with geysers opening up, this is where you would do it. But each one of those impact sites definitely resembles what would be a water impact zone. And none of them leave any traces, and none of them have any evidence of any impact site, and none of them have ever impacted the Earth at less than 90 degrees. But again, all of that is based on the simple observation of one phenomenon in the sky that is predictability of meteor showers, which they study in conjunction with the sun. So based on lights in the sky flashing in once or twice a year in the seasons, they have completely proven, although no one's ever seen it, that the Earth is pockmarked with a series of meteor impacts from giant space rocks that no one's ever seen, that we know are there because of all the signs on the Earth. So that's pretty much it for the meteors and what we know, and we got to incorporate our southern apex south toroidal observations going forward.
Killer.
I think I took out a bunch of slides at the end, mostly just map stuff, video stuff, magnetic field stuff, black sun stuff. Yeah, I can see why I didn't use any of this. Yep, so that's tonight's presentation, boys. What do you guys think?
Fantastic Prezi, bro. Awesome.
Yeah, that was great.
Nice. I like how they use some science and then use a whole bunch of speculation and non-science, upon which they built more non-science to create crazy speculation.
That's my favorite part. It's like, you guys like dinosaurs? It's like, yeah. Well, they all died because of a meteor. Oh, no.
Yeah, so like, both meteors and dinosaurs are definitely real.
They just swoop up the twofer.
The other.
Right.
So you know how real it is.
Great presentation, Shanji. This is one of my favorite subjects. And
meteors are stuff in the sky.
Yeah. Well, did Alan G close his stream?
No.
Yeah.
Shane G closed his stream.
Yeah, that was Shane streaming. And yes, he ended it.
Yep.
Oh, okay. Yeah. Anyways.
Need to totally throw you off.
No, I was just gonna say it's one of my favorite subjects, so I enjoyed this presentation.
One of my favorite parts was when that guy got self-rused and he bought mining rights to something that doesn't have anything in it.
Yeah, I don't know if that's part of the lore or if that really happened or if that dude was just Googling. Like,
either way, it's an awesome story. I'd like to think it happened.
Well, imagine that you believe in heliocentrism, and thus all meteor craters have iron-rich ore, right? Because of course water came to Earth from meteors as well, right? So then meteors are
Right.
like natural resource treasures that you seek, and you get there and it's just fucking dirt. You're like, oh, and then you get there like 226 more times, and it's always dirt. And you're like, oh, you know what it is? It must have vaporized itself on impact, and that's why none of the goodies that we know are here are actually here.
I'd like to think that the remaining dinosaurs launched a counteroffensive against the meteorites, and they wiped each other out in a mutual battle to the death.
There's no evidence of dinosaurs, but you know what happened? The evidence for dinosaurs got wiped out by meteors, and then the evidence for meteors got wiped out by volcanoes.
No, they got wiped out by the dinosaurs.
There's no evidence for anything, but they definitely both existed.
I
Kind
got
of
you,
like,
but
what's up, Jackie?
I want to go back, and I got to go back and watch it from the beginning. I got here late, but it made me want to go back and watch it from the beginning, so it's obviously really good.
Nice, thank you.
Nice. And Jackie is known for not going back and watching things unless it's really good. So.
It's true.
I also tried to keep it under an hour, and we did that, so perfect.
Nice little 60-minute piece on meteors.
Yeah, that's one of the frequently banned globe proofs. Like, well, if Earth is flat, dummy, what are meteors? Well, sporadic radiant meteor impacts are studied widely through Harvard Radiology Survey, and it turns out via the North Toroidal Impact Point and the Hellion and Antihelion actually aren't proof of heliocentricity at all because they coincide with the solar sidereal time. So there's that. And they'll be like, "What? I don't know anything about meteors. What did you just say?"
You're a meteor.
Yeah. Well, all the science that they have is on those light shows in the sky, and from that they're like, oh, you know what it was? A giant space rock. Yep. So you think they'd have evidence for giant space rocks, right? But what I showed you is all they had. So it's pretty funny.
Turned out their evidence was a lack of evidence.
Yeah, and then it could just be like sporadic electromagnetic discharge of some sort. There's also a theory that like maybe the heavier elements don't orbit around the solar system and fall to Earth via gravity, but there is some sort of electromagnetic pressure gradient happening, and perhaps heavier elements are somehow distilled and then fall through the atmosphere to the Earth. And that's what we see, and then that's what we find. There's little chunks of rock or whatever.
No, that's too mechanistically coherent.
I heard someone put it together much more coherently than me, and I was like, that makes way more sense than rocks containing all the world's most valuable things rocketing through the solar system and happening to impact our planet to bestow us with the materials of life.
Well, you know what they say. We come from the stars, or whatever.
Everything is stardust. That's what Disney princesses are made of, or whatever.
It's the secret ingredient.
Well, that's a lot of talk about what they're not and how the relationship doesn't exist. But I think that we're leaving the Globey here still asking the question of the flat earthers, what is it that we are observing above? You know what I mean? What's producing that heat map? And again, if we're going to play around in the land of conjecture, this is where I would come in with a theory that I've been playing with for a while. And I relate it to the same mechanism that produces the electrostatic situation that we exist in here, in the field inside of which we exist, which causes gravity, which causes lightning. And I'm sure you guys are all fairly up to date on how lightning, the appearance of it when it is arcing, is completely different at very much higher altitudes. They create shapes called elves and sprites and stuff instead of the jaggy lightning bolty stuff that we see at the surface because of a lack of atmospheric pressure up there. But I see a relation between those two. Like you say, they produce a heat map. They're cyclic. They are predictable based on sun and moon position mostly. And I'm seeing in my own mind, what would an arc look like from above that is producing the voltage differential inside of which we live? That what if, because it is constantly being overdriven from above at our altitudes, maybe it is also being constantly overdriven in voltage from above that, the next threshold up, so to speak. I don't want to use the word firmament, but you know it's coming. the layer that is in between, the one that keeps our atmosphere in, etc., the one that also keeps the water out. So picture in electrical terms an electrical arc and what it would look like to go through a fluid. I think we on this side of the barrier, looking up at it, almost in the opposite direction of its travel as it moves toward ground, would appear as a point source, would appear like it's moving across the surface, so to speak. And that's why we always see them moving in a certain direction in orientation to ground. That I think that we're also witnessing overdriving of the voltage potential from above what we even consider to be above, if you know what I mean, through a fluid. I think that's what arcing would look like. And it's part of the mechanism that produces the gravitic effect inside of which we live. And the voltage potential that Feynman put in his textbook showing 100 volts per meter as we go up. I think those are all intertwined mechanistically. How's that sound?
Way better than I was trying to stumble around in the dark or whatever. Or that's definitely what I meant, though. Everything Stone just said.
Feel free to steal it and perpetrate and spread it out. Sure.
I would go with Stone. It's like if I'm going to enter the realm of coming up with a hypothetical, it's going to be within the model of an electromagnetic dynamic universe and what we know about electromagnetics. And so I'm just going to operate from that.
Well, I'm thinking more in the electrostatic realm.
Oh, okay. I misspoke.
But you're almost there, right?
Right.
Yeah.
Right.
Yeah. An effect of the gradient. Yeah, I mean, I was kind of loosely blaming the pressure gradient, which would be electrostatically based and induced, right? So, and then, I mean, I was kind of loosely associating all those things together and just calling it an explanation is where I was at with it. But yeah, and we are, to be clear, we are definitely guessing and putting what we think it might be, right? Because their explanation obviously is not dynamically sound, doesn't hold anything, so we can decide what we think it is. And I think our explanation makes way more sense and works with all of the other dynamic causes that we think.
Totally. That's the difference between us and them is when we make shit up, we tell people that we're making shit up. It's
right. To be clear, we don't know, but we think it might be. Nope.
Well, I'm doing everything but affirming the consequent. I'm saying, all right, well, this looks like it is, causally attributed to this, connected to that, that these appear to be mechanistically related, and their physics would jive, so to speak. I'm merely stating that it's possible and that the relationship appears to exist. I'm not creating a fucking law based around it. You know what I mean? I'm not writing formulae yet because I'm not even able to measure it.
If we were to frame it via a null hypothesis, we would have failed to falsify it thus far.
Everything he said
Fair.
Made sense. I'm surprised, but it made sense to me. Things don't usually make a lot of sense to me when I come in here. That everything he said just made like perfect sense. Thank you.
Mission accomplished.
Nice. Good stuff. Alan, you ready to wrap it up there? Are you still there?
Yes, sir. We just need to do our mandatory brushtail babe ad. So let me get Liliana out here. All right. Release Liliana.
Hello? Hello there. Oh, yes, the Brushtail Coffee. The ongoing adventures with the Brushtail Coffee. And I tell you, the adventures never stop. It just is so amazing. So I guess I may or may not have shared this particular feature about Brushtail Coffee. But one of the things that I noticed is that whenever I drink Brushtail Coffee and go out, I can, for at least an hour or two, I can understand every language being spoken. So, I mean, it's great, but it's also so awkward because I'm just getting to know everybody's life stories. And I mean, and they don't even know it. They don't know that I understand their language, even obscure ones. So, oh my God, Brushtail Coffee, it just really does a number to the brain. And to your life. Oh, you have to try it. Plus, it's totally delicious. And is Kat going to tell us about the merch store? Also, I just retweeted a tweet with the hashtag Aether Cosmology, which Aether is spelled with an A-E, and then the word cosmology. And if you hashtag it, you'll find it on Twitter. And basically, I've given you the handles of all our learned colleagues and where and how you can support them. So please do that. And then, of course, don't forget to drink the delicious brushtail coffee. Yep.
Thank you so much for that ad read, Lily. And one more thing, if you could let everyone know that you're not being held against your will and you're doing the ad reads of your own volition. Just for legal purposes, you know.
I guess.
All right, guys, we're going to switch over to an ad read to Kat now.
All right, everyone, bye. Yeah.
Liliana's safe. No one's making her do anything. It's fine.
Awesome.
We just wanted to say thank you to everybody who has placed their orders this last week. This has been such a successful launch for Aether Cosmology with merch. We have a great, small select group of people that have ordered those hoodies, those original OG lifetime members. We thank you so much for stepping up. Everybody ordered a lifetime membership, and you will be getting your cards and your special membership number. For those who haven't yet, you still have until midnight tonight. And you can also continue to get those lifetime memberships on Alan's coffee shop. But the merch will be coming down at midnight. So if you want to order a sweatshirt or a t-shirt or a hat, you want to get in there now and get those ordered. And we have been able to help a few people who are outside of the US. So if you are one of those who is outside of the US and want to order something, get a hold of me on Discord, and we have a process to help some of you out with that. So, and thank you everybody who has ordered. This is just going to be a great first launch to our merch line. So thank you.
Awesome. Thank you. And with that, we are going to wrap up. Tomorrow, we're taking a break, and then we'll be back again on Thursday for a relativity discussion on the OmniTalk Discord server for some reason. And then we'll be going to Twitter for the old Friday community Twitter space. So stay tuned for that. And then Saturday, I have a debate lined up with Astronomy Live on the Red is Rhetoric channel. There'll be a watch party here on Aether Cosmology. I'll be streaming it as well. That'll be at 8 p.m. Eastern, so tune in for that. Maybe we'll get to the bottom
Astronomy
of Aries
Live.
measurements. Yes.
Is that the same guy who was at the table with Witsit and Tim Pool?
Indubitably.
That guy?
Yeah, I know.
Do I sound like Bruce?
Yeah.
That guy? That guy? Oh my God. Oh my God. Okay. Oh, Jesus. I feel so bad for you. But good luck, man.
Yeah, it's going to be awesome. All right. See you guys.